Hey, welcome to the next section. My name is Canoe Grover, and today we'll be talking about line plots in Tableau. So the data set that I'll be using for my topic of discussion is the Superstore data set, which you can find on the bottom left-hand side of your home screen. So when double-clicking on that and going over to the data source, we can see the different types of columns and rows contained in our data set. So essentially, the Superstore data set is a dataset containing the sales of products from a global superstore over a time span of 4 years, from 2016 to 2019. So, before we get into the meat of today's section, I just wanted to show that in this data source section, we can see all the different columns, including the order date of a product, the ship date of that product, the mode of shipment, the country, city, state, customer name, etc. And we can also see all the rows associated with those column names. Cool. All right, let's get into the meat of our section. So if we go over to a new blank sheet, we can see that in this section we're going to be covering line plots and their functionality. Line plots typically involve viewing relationships between a categorical variable, such as a date or a description on our x-axis, versus a numerical variable on our y-axis. So if we go over to the Show Me button on the top right hand side, we can see all the different types of visualizations that Tableau offers. However, in this section, we're going to be talking about four main types of visualizations: the continuous line plot, the discrete line plot, the dual line plot, and the scatter plot. Perfect. All right. So before we get started, let's take a look at these two bins at the top, the column bin and the row bin. So the column bin essentially corresponds to the variables of on our x-axis of our line plot, which is the categorical variable, and the row bin corresponds to the numerical variable, or the columns or the rows on the y-axis. So usually on a line plot, you're going to want your x-axis to reflect some sort of date, and your y-axis to be anything that you want to see change over time. So in this case, why don't we inspect our data source data set a little bit more closely. So if we go to the left-hand side of our screen, we can see that this contains all the different types of columns in our data set. So why don't we select order date as our column value, which gives us all the years which are contained in our data set, along with sales as our numerical variable. So after doing that, so when we put our columns and rows in Tableau, we can see that Tableau automatically assigns us a default graph type. So in this case, they assign us a discrete line plot. Now, what's the difference between a discrete line plot and a continuous line plot? And as the name suggests, a discrete line plot is not continuous over a given interval, whereas a continuous line plot is continuous. And I'll talk about this in a few more moments when we go into depth on the differences between these two. So a really easy way to distinguish between the two is that we can see that our column bin, if it's a discrete line plot, our column bin is going to have a blue highlighted value, whereas our row bin is going to have a green highlighted value. And for a continuous line plot, we can see that both our column and row values contain green values. So that's pretty much a rule of thumb. If you see both of them containing green, you can safely assume that it's a continuous line plot or vice versa. So a more in-depth way to discriminate between the two is, say I wanted to observe the relationship between the month of the order date and the sales, instead of just the years that we have currently. So if we go over to the drop-down menu in our column value, we can change this over to month. Cool. And now what we get essentially is we get a really cool line plot that gives us the sales for every values for every month and the corresponding year. And what I meant by this is that the continuous line plot, what we have right now, does in fact take every single x over a given time interval. For example, it has values all the way from January 2016 to December 2019. And we can verify that this is continuous by seeing over here the continuous option is checked. Okay, cool. So if we try to do the same exact thing for our discrete line plot, we're going to see that there's a little bit of a difference. And I'll show you that difference just in a few moments. So if we go over here and try to change this over to month, what we see instead is that instead of getting every single month and every single year on our x-axis, we can only see that our discrete line plot does not take every x over a given interval. If I filter by the month instead of the year, you can see that on our x-axis, we only get the months from January to December. So this value over here, $95,000 in sales, is the aggregate of the January sales in 2016, January 2017, January 2018, and January 2019. And that's true of every single value on this discrete line plot. And that's what I meant to highlight that difference a little bit more clearly. Okay, so let's go back to our original data set, our continuous line plot, which is a lot easier to work with in this case. So we go over here. Cool. All right. So say we now want to observe the distribution of the order date and sales and maybe plot that against the distribution of the order date and the profits associated with those sales. So profits in this case, again, is a numerical value that we want to plot on our y-axis to see the relationship between the date and the profit. So if we go over to measures, we can select profit and drag it over to our row column. And what we get is two different graphs completely. One shows the relationship between date and sales. The other shows the relationship between date and profits. Let's say we wanted to aggregate this data into just one singular graph that can compare the two. To do this, we can just drag our profit over to the left-hand side of the sales, and immediately we get a graph that contains both line plots, the orange one being sales and the blue one being profits. So this looks a lot like one of our other graphs that I wanted to talk about today, which is the dual line plot. Essentially, both graphs take in two line plots, but if we click on the dual line plot, what we can see is that there's a little bit of a difference. Our graph now changes to have a second x-axis instead of just one. In this way, the dual line plot is almost trying to fit the two curves to be similar to each other. And what I mean by that is you can see all the overlap over here that we do not see in our continuous line plot. However, these values are obviously distinct because we have two different y-axes. We can see that if we hover over the blue line, we can see the blue line corresponds to profit, which is associated with the left-hand y-axis, whereas the orange line of sales is associated with the right-hand side of the y-axis. But some of you may think this is really trivial. Why do this at all when we can just see both distributions for what they are? Why have two y-axes? But this is actually really important because ignoring the actual dollar amount that we get from the profit or the sales, we can see this allows us to observe the relationship between the two line plots a lot more clearly. For example, a rapid jump in sales also indicates a rapid jump in profits, or a rapid decline in sales can also indicate a rapid decline in profits. And this is really key in determining a relationship between these two line plots. Okay, so before we get into the next section of scatter plots, I just wanted to give out the code word for the attendance form that'll be released along with this lecture. So instead of being a singular code word, we're gonna have a 5-word code word inspired by our facilitator, Avik Sethia. So our code word for today is gonna consist of 5 words. It's gonna be Jack in the Box Games. Again, that's Jack in the Box Games. Anyways, let's move on to our next part of this section for scatter plots. So let's go over to a new sheet. Um, so initially we want to, so scatter plots typically show the relationship between a dependent and an independent variable. So let's take some parts from an example that we just saw. Um, this example compared the distribution of profits and it compared the distribution of sales. But now in this case, let's describe sales as our independent variable and profit ratio as our dependent variable. Essentially, the sales impact the profits. So if we go over here and we drag over sales to our column bin, which is our independent variable, and we find profit ratio and drag it over to rows, which is our dependent variable, we see that our graph looks a little bit wacky. We only have one dot on the top right hand of our graph. And the reason for this is this dot is essentially the aggregate of all the products um, in our data set. And that's not really useful to us. We want a little bit more of a better visual when it comes to observing the relationship between the sales and the profits. So let's try to break this down a little bit. So if we consider our data set consists of a bunch of different categories of purchases. So if we look to the left-hand side of the screen, we can see that we have a section category. And if we drag the section over to this variable colors, we can see that the categories, the furniture purchases, office supply purchases, and technology purchases make up the total aggregate data. And that's represented by these three different dots on our scatter plot. But this still isn't really conclusive of our data set. So instead, we can consider that these three categories actually includes a lot more subcategories. If we look on the left-hand side of the screen, we can see this subcategories section. And if we drag that over to the color section, we can now see a bunch of different subcategories associated with the original main categories that we just saw. And this now makes it a lot easier to view on our eyes. And now we can see that this scatter plot shows a negative relationship between sales and profit ratio. As sales increase, profit ratio decrease, and vice versa. As sales decrease, profits increase. All right, thank you so much. That wraps up the end of this section.